Math Quiz. In this video, I am going to explain how to calculate Karl Pearson's coefficient of correlation using direct method. If x and y are small numbers and x bar and y bar are fractional, then we use the formula r is equal to n sigma xy minus sigma x sigma y over under root n sigma x square minus sigma x the whole square under root n sigma y square minus sigma y the whole square. We make use of this formula to calculate the Karl Pearson's of coefficient of correlation using direct method. In our previous method, that is in actual mean method, if x and y are small numbers and also the value of x bar and y bar are in terms of whole numbers, we make use of actual mean method. Suppose if x bar and y bar, the arithmetic means of x and y are fractional, something like 12.7. X bar takes value 12.7 or y bar takes the value 17.2. Something like that. If it takes a fractional value like this, then we have to prefer the direct method to calculate the Karl Pearson's of coefficient of correlation. Now, let us discuss about this in detail by taking this example. Calculate Karl Pearson's coefficient. Here the variables x and y has taken the values 8, 11, 15, 10, 12, 16 and corresponding values of y are 6, 9, 11, 7, 9 and 12. Let me first write down the formula to calculate the coefficient of correlation. So we make use of this formula. So for that we need the values of sigma xy, sigma x, sigma y and sigma x square, sigma y square, like that. So for that, first let me construct a table, whereas the first column consists of the given values of x and the second column I am going to calculate x square. And the third column consists of the given value of y. And the next column I have to calculate y square and the last column I have to calculate the product of x with y, that is xy. Here capital N represents the number of pairs. Here totally we have 1, 2, 3, 4, 5, 6. So totally we have n is equal to 6 pairs of observations are given. So now let me first calculate x square. X square, that is 8 square. 8 square is square of 8 is 64. 11 square. 11 square value is 121. 15 square is 225. 10 square, that is 100. 12 square, that is square of 12, 144. 16 square, 256. Like that, here we have to square the values of y2, that is 6 square is 36, 9 square is 81, 11 square is 121, 7 square is 49, 9 square is 81 and 12 square is 144. Next we calculate the product of the values of x with y. That is 6 8s are 48. 11 9s are 99, 15 11s are 165, 10 7s are 70, 12 9s are 108 and 16 12s are 192. Now let me add all these values to get the value of sigma x square and sigma y square and sigma xy. After calculating all these values and substituting in the formula, we get the Karl Pearson's correlation coefficient. Now let me first add values of x, that is 8 plus 11 plus 15 plus 10 plus 12 plus 16 equals 72. So sum of the values of x is 72. And sigma x square next, 64 plus 121 plus 225 plus 100 plus 144 plus 256 equals 19. That is, sum of all values of x square is 910. Next, sigma y, that is 6 plus 9 plus 11 plus 7 plus 9 plus 12 equals 54. That is, sum of all values of y is 54. Next, sigma y square, we have to calculate. For that, we have to add 36 plus 81 plus 121 plus 49 plus 81 plus 144. We get the total as 512. That is 512. The last one, we have to calculate the sum of the values of xy. For that, let me first add 48 plus 99 plus 165 plus 70 plus 108 plus 192. I get the total as 8 48 plus 99 plus 165 plus 70 plus 108 plus 192. We get the total as 682. So now we get all the values of sigma x square, etc. So let me first substitute all these values in the given formula. We get, now let's substitute all these values in the given formula. We get r is equal to n is number of pairs of observation 6, sigma xy value is 682 minus sigma is 72 and sigma y, that is 54 over under root n is 6, sigma x square is 910 minus sigma x the whole square, that is sigma x is 72, so 72 the whole square, and under root n is 6, sigma y square is 512 minus sigma y, that is 54 whole square. So now let me simplify all these values. We get 6 multiplied by 682. We get 4092 minus 72 multiplied by 54. We get 3888 over under root. Now 6 multiplied by 9, 10 minus 72 square. So you get the value 276. Next, under root 6 multiplied by 512 minus 54 square. So you get the value as 156. That is 156. By simplifying this, we get the value 4092 minus 3088. You get the numerator value as 204. 204 over. And now for the denominator, 276 under root, we get the value 16.613, etc. We multiply this by under root 156. We get the total as 207.4993. So we have to take up to 3 decimal places, that is 207.499. So by dividing 204 by 207.499, you get the total as 0.98. So the value of R is 0.98. So based on this value, our interpretation about the coefficient of correlation between the two variables, given variables x and y, is there exists a high positive correlation between the two variables. There exists a high positive correlation between x and y. So based on this value, our interpretation is, because R takes the value 0.98, if it is 0.9, there exists a high degree of positive correlation between the two variables. Let me show you the graphical representation, that is scatter diagram of the given variable x and y. After plotting all these points, we get a line like this. There is an upward movement, so there exists positive correlation, and here the points are clustered closely around a line. So there is small deviation of the points from the line. Some of the points having a very small deviation, so there exists a high degree of positive correlation, isn't it? So based on this diagram too, we know that there exists a high degree of positive correlation. But using Karl Pearson correlation coefficient, we get the value R is equal to 0.98. This gives you a much clearer idea about how much the two variables are closer to each other. So what is the type of relationship exists between the two variables? So there exists a high positive correlation between the two variables. Hope you got a clear idea about how to calculate Karl Pearson's correlation coefficient using direct method. Thanks for watching. See you again in my next video.